So in this video I'm going to calculate the number of 1 functions from a set A to set B, where the cardinality of A is equal to say M and cardinality of B is equal to say N, and also the condition that M is less than or equal to N. This condition is important because if cardinality of M is let's say 4, A1, A2, A3, A4, and cardinality of B is 2, B1, B2. So the first set is mapped to first element is mapped to B1 and the second element is mapped to B2, and there is no different image that is different from B1 and B2 to map A3. Like we cannot map A3 to some distinct image that will be distinct from these B1 and B2, the images of A1 and N2. So it won't be 1 1, because if we map A3, then f of A3 is equal to f of A2, but that doesn't imply A3 equal to A2, because A3 and A2 are distinct, and so this is a condition that should hold for 1 1 function. This f of x1 equal to f of x2 should imply x1 equal to x2, or x1 not equal to x2 should imply f of x1 not equal to f of x2. This is a condition for 1 1 function. So let us define a mapping f from A to B, and the cardinality of set A equal to M, cardinality of set B equal to N, and also M is less than or equal to N. So the condition for a function is every element of A has at least and at most one image in B. So A is the domain here and B is the codomain. So A1 is mapped to one element and only one element. So an element of the domain should have at least one image, and it shouldn't have more than one image. So there is only a unique output for A1 under the function f. So in the case of 1 1 function, no two distinct input have the same image. That is, for every distinct input, it has a distinct image. So A1 can be mapped to B2. If A1 is mapped to B2, then no elements in the set A can be mapped to B2. That is a condition for 1 1. So when we are counting the number of 1 1 functions, let's consider the case of A1. So how many possible choices are there? How many elements can be mapped from A1 to the set B? So there are n possible choices for A1. A1 could be mapped to B1, A1 could be mapped to B2, A1 could be mapped to B3 up to Bn. So there are n choices. And for A2, how many choices are there? If A1 is mapped to one element from the set B, then A2 has only n minus 1 choices. And likewise, A3 has n minus 2 choices. And AM has n minus m minus 1 choices. So when we do the permutation, A1 has n choices like this. This is one. This will all count to n choices. And from this A2 starts, A2 has n minus 1 choices from every n branches, so n into n minus 1. And from the end of the A2 branches, the branches of A3 starts. So every n into n minus 1 branch, there will be n minus 2 branches, so n into n minus 2. So what is the total number of 1 1 functions? So as we have seen, the total number of 1 1 functions is n into n minus 1 into n minus 2 into up to n minus n into into n minus m minus 1. So these are the number of 1 1 functions, and this can be put into like this also, n npm, which is n factorial by n minus m factorial, where n is the cardinality of p and m is the cardinality of a. So npm വേണമെങ്കിൽ simplify ചെയ്ത് n into n minus 1 into n minus 2 up to n minus m minus 1 into n minus m factorial divided by n minus m factorial. This can be cut, so we get the expression here. So the number of 1-1 functions from a set A to a set B where cardinality of A equal to m and cardinality of B is equal to n, and also m is less than or equal to n, which is a condition for 1-1 function to be possible. So the number of 1-1 functions is npm, which is n factorial by n minus m factorial.